Morning. Today we're going to try something a little bit different. We're going to try a 1 hour build, and we're going to build a rock, paper, scissors game. And we're going to do it in Elixir this time. For those not familiar with it, Elixir is a modern language built on the Erlang virtual machine with great concurrency capabilities, and in this case what really helps us is a very nice live coding environment called LiveBook. As you can see, I've already got a blank notebook open, so we can dive straight in. So we're going to start off by creating a basic game class. And in here, we're going to have a super simple play function. Now we're going to start off with a single player game. So this is going to be just one player's choice. And in here, we are basically going to generate a random choice for the computer. Let's rename this actually to player choice, and now we can have computer choice is random choice, and we're going to define that as a new function, and that can be an array of rock, paper. These are Elixir atoms. And we're just going to pipe them into the enum.rand function. That's it. Now I'll take a random choice from there. So computer's choice is random. And then what we're going to do is capture a result, which is going to be a judge. And player choice and computer choice. Now I can implement that result function. Add a judge function. And that's going to be, we're going to have multiple clauses here. The very simplest one is going to be when we have the same value. Both have chosen rock and rock, or paper and paper, or scissors and scissors, so on and so forth. And in that case, we can use a simplified form and just return a draw. Now, the other clauses are going to be all the different when clauses. So we judge, and we're going to have a, for example, rock, paper, and we're just going to return here the winner. There are obviously lots of different ways to implement this kind of functionality. I've gone back and forth on them in the past, and this seems to be the most versatile, at least for now. But we might change it even in the course of this build. So rock and scissors, rock wins. No, we don't need that. We need this. There we go. Rock and scissors, paper and scissors to scissors. So Elixir automatically returns the result of the last statement. So all these functions will just return the atom there. So that will return paper because paper wins. And I'm going to have scissors, paper, I'm going to do scissors, we're going to have scissors and rock, and we're going to return rock. Okay, right, so that should be the core of what we're trying to achieve. So let's create a new box and just do game.play and put in rock. What we should get back is just the output of this choice. Yeah, so paper wins, rock wins. Okay. Now, obviously, this is not necessarily the most useful thing because we don't know what the computer played, and the output isn't great either. So let's do some stuff with that result. Let's transform it and say it'll be really nice, first of all, to see what the two choices were. So we can do how shall we do this? Shall we do it as a string? Let's do it as a simple string to start off with. So we can do a conditional here, and we can say if the result is the same as the player choice. So we pin that variable there. Then what we do is we can do a string here and say, how can we say? We can say player choice versus computer choice. And then we can say, in fact, we can just do result. No, we can do player choice, result's going to change. Wins, and then we know this is a win situation, so we can do congratulations. And we're going to have basically the same thing when it's the computer choice. So we're going to copy that and do computer choice wins, and then we can do a try again. And finally, if it's not any of those, it'll be a draw. And in fact, we can let's copy that message again. Player choice versus computer choice, and then we can say it's a draw. Try again. Okay. It's a case rather than a cond. And okay, we're not using the results and press, but I think we can just do that. Right, let's see. Rock versus paper, paper wins, try again. Rock versus scissors, rock wins, congratulations. Okay, so that is in 7 minutes, 8 minutes, the simplest possible implementation of a rock, paper, scissors game in Elixir. Obviously, there's quite a lot we can improve here, both in terms of the code itself and in terms of functionality. I think this is a good point, though, to save it, and we're going to save it as build Elixir. Save that. All right. Okay, so what can we improve about this, first of all? What can we tidy up before we improve functionality? I think there's obviously quite a lot of repetition here. We can tidy up this output for now. So we can do present results. And what we're going to do here is we're going to take a player choice. We're going to take a computer choice. And we are going to take a winner or a result. But we can do this rather than have a conditional. We can make it so that, for example, if here it's also player choice, but we can pattern match this this argument. So we can do player choice. So this is when the player wins, and we can do, essentially, we're going to break this case statement into three clauses for the present results function. So we can do again fp present results player choice computer choice, and we can do computer choice. So when the result is the same as the computer choice, then the computer is 1. And we can use this clause here. And finally, we can do, we copy that, but when it's a draw, then we can use this statement here. And that means that we can get rid of that and just say present results player choice computer choice. I need to save the result here. Okay, let's try that. It should behave pretty much exactly the same. Now, the other thing that is annoying me is that we've got bad capitalization here. That should be an uppercase P, and probably they should be uppercase there and there as well. So what we can do is we can turn those atoms to strings and then capitalize them. Where's the best place to do that? Because we can have a present atom, and I'll take an atom, and it will do atom, and then pipe that into a atom.toString function, and then we can pipe that into string.capitalize. That should give us a nice uppercase capitalized string version of the atom. And now we just need to make use of it in these functions. So what I'd like to do is change these three variables as at once, really. So I want another clause here, fp present results, and we want player choice computer choice, and then we want result. We might need to rename those other clauses though, because otherwise this will always match and the others won't. But we can come to that in a second. So what we're going to do here is we're going to just take these three atoms and capitalize them, and the three arguments, capitalize them, and then call the function again. So we're going to do yeah, that's right. Player choice. Only thing that's going to be a challenge is that's going to change. It's going to be an uppercase string. What if we do it at this stage? Is that a problem? Is there a nicer way of doing this? It probably doesn't matter. So I can do player choice is equal to player choice, pipe that into item, and the same for computer choice. Present atom, and we can do the same for result. Okay, and then what we can do is present results inner. Just rename these three clauses so that they're a different function. And then we can just call present result with the three arguments, their choice, computer choice, and result. Okay, and this is going to change, and it's going to be the string draw, I think. Do we really? Yeah. Yeah, that should be fine. Oh yeah, then we need to call that as in there. Okay. Yes, that is working as expected. What else can we do to simplify this code? We could extract this summary. Yeah, let's quickly extract that summary. Try it. Player check. And then we're going to do, basically it's going to be this string. And then instead of that there, we're going to have, although I think it's actually going to make the code longer. It has made the code longer. Do we care? Now I'm not even going to bother doing it. Duck out of that. Okay, so in that case, what else do we want to do next? We're only about 15 minutes into our hours session, so we can definitely improve this functionality. Now, the elephant in the room is that we don't have any automated tests for this. So we can choose to implement some automated tests. But I feel like for entertainment purposes, I'd like to focus on functionality this session, and maybe next time I can beef up my my testing skills. So what would be nice to do is have a slightly more graphical interface. So maybe just three simple buttons, you press one and you see your result. LiveBook has a great module called Kino, so we can come out there, search for a package and find Kino, and that will let us, once it's installed, we can now create components on this on live cells and smart cells. So, for example, these are all created with Kino. We can have maps, we can have charts, we can have various things. They each require their own packages, so I'm not going to install them now, but it allows you to build quite nice interactive functionality. So what we're going to do is we are going to, in order to accept inputs, we want to turn this static module into a gen server, which is a process that can subscribe to updates from buttons that we create with Kino. So what we're going to do is we're going to say use gen server, and then we're going to implement a method called def start link, which takes any arguments we need here, but we don't need any, we don't care. And then what we're going to do here is we're going to do genserver dot start link. I'm going to give it the name of the module. The arguments are going to be whatever they are, we don't care at this point, and we're going to make sure we've got a name here so that it can be addressed by name. And then we're going to have, we need to define a init function, which again, we don't care about the arguments for now, and we're going to do, now, one thing that I've found a little bit tricky with LiveBook is knowing when processes are starting and restarting and whether they've picked up the new code or are still running and things like that. So what I'm going to do is, first thing I'm going to do is I'm going to take a, I'm going to output a string that says game gen server initializing, and we're going to have here a random seed just to know that this has changed. So I can do a seed or just a random. It doesn't matter what we call it. Just put it there, and we can do. I think it's in math module, isn't it? Let's do headstocks.pm. Search for random. Not enum.random we want, is it? I'm sure there was a random number function. It's in Erlang math random. Okay, so I think it's rand. Oh, rand.uniform. Okay, yeah. Okay, so that should give us a random number. So when we run this, we get an error. That should be a module name. Right, okay, so that still works exactly the same, but now what we can do is we can do gen server. Let's assign it game is equal to gen server dot start link, and then we give it the name of our module. We give it some terms, and that should. Okay, so what we need to make sure here is that we return an OK and a state, which in this case is just going to be a blank map. And let's try that again. Okay, yeah, we're not seeing that let's pipe that through dbg, of course, because we're not returning it and we're not printing it. So let's try that again. And we can see, that's interesting. That's very interesting. So we're not seeing that initialization method each time. Let's give it a unique name. Let's see what the correct way of restarting it is. Elixir game server restart. Okay, for the purposes of this, if we give it a name, this will clash every time it tries to start a new one, so these will be a new unique. And I want to force this to restart the whole thing. And server dot stop. Okay, and then we can do game and that can be module game is okay, because we've already started it. And from now on, we should be able to see, yes, there we go. Okay. Why do I only get, why do we not get that initialization message sometimes? Okay, fun and games with processes. I'm going to put that down to my ignorance of live view for the LiveBook for now. But anyway, that should be enough for what we need to do. And then what we can do is we can create a frame, which is a keynote.frame.new. And we can create some buttons. So we can do rock, paper, scissors, if I can spell it. We can pipe that into enum.map, and we're going to pass an anonymous function, which is going to be the button. And in here, what we're going to do is we're going to, in fact, that's not going to be the button, that's going to be the label, I think. And what we can do is we're going to create a new button, which is going to be a keynote.control.button, and the label is going to be label And then what we're going to do is we're going to subscribe to that button. So we're going to do keynote.control.subscribe, and that's going to be the button, and we're going to give it a tag, which is going to be the label. And then finally we're going to append this to the frame. Keynote.frame.append button. We need the frame first. And then over here we're going to do keynote.render our frame. And we're going to save our frame and our state. Now when we run this, we should hopefully see 3 buttons. No, we can't. Why? No function close matching in button. What have I done wrong? Okay. That has to be a atom.toString. I believe we can also use A to S. There's a kernel function, but let's see. Okay, we can't kill it because it doesn't start. Okay. So there we go. Now we have 3 buttons, and we click them, and they do nothing because we haven't implemented the handle info buttons, messages, handlers, which we can do next. So over here somewhere we can do def handle info, and let's see what we get. We get a tuple, which is the label message, and then we see it's a type click on the origin. I don't think we care about the secondary map, but what we can do is when we do a handle info, we get that, and there is the choice. That's going to be a player choice. And then we get some other stuff that we don't care about, and I believe we get the state in the second argument. Let's have a look at the join server handle info. Yes, we get a message and the state. So that's going to be the state. And we always have to reply with a no reply, I think. Yes, we can reply with no reply or stop. But we're going to do a no reply here, and we're going to return the state. And what we want to do here is, well, we've got player choice, right? So we can do play, and that will return our results. So we can do results is equal to player choice. And then what we should be able to do is do keynote.frame.render. That should refresh the entire frame. Renders the given term within the frame, and it outputs the existing frame contents. Right, so then we can do frame, results. Let's see if that works. Because it's state.frame. Hey! Now, interestingly, we have no way of trying again at this point. So what we want to do is have one additional button, which we create after this, which is retry. Retry is equal to keynote.control.retry. button, and that can be a retry. And this one doesn't matter for now. And then we can do keynote.frame.append, and we can append the frame, we can append retry. Now again, we will need a handle info for that, which is going to be, we're going to put it above here because we're actually going to match the key. Def handle info retry underscore, because we don't care about the second part of that tuple, and we're going to grab with state there too. And right here, we want to start the game over basically. So we don't need to reinitialize the frame, and we don't need to re-render it. We do need to return a no reply and state. And I think if we extract these buttons in a function that adds these buttons to the frame, or actually we don't need to recreate the buttons every time, do we? If we put the buttons in state, then we can reuse them. I think that will be better. So we need to adjust this slightly. But I think if we do this, that will return the button. So we can do buttons is equal to that. And then in there we can do buttons. We can probably rename that to something a bit better, but what we should be able to do is we can match here, we can pattern match our state, and we will have a frame, which is frame, and we will have buttons, which we're going to bind to buttons. And then what we should be able to do is just clear the frame and reappend the buttons. So we can do keynote.frame.clear, and then that'll be our frame. And then we can do keynote. In fact, we can pipe these. This is all pipeable. Frame. Pipe that into clear. Pipe the does clear return the frame? It's not pipeable. Okay, it's fine. It's not going to work. So I'll remove that. Remove that. Keynote.frame.append. Can we append multiple terms at once? I wonder if that's going to work. Let's try. Because it's a state frame. And we need to pass the frame here. Okay, so pick a rock, it's a draw, try again. Oh, come on, really. Where are we? Game handle info. Line 35, I think. Oh. that should create it. Again. Okay, let's try A2S in this case. No, I think that might be from Ruby. Anyway, atom dot toString. I'm not going to be able to stop because it crashed. Now we can do that. Okay, why does retry do nothing? Let's do a starting. Oh, because we never actually subscribe to the button. Keynote.control.subscribe, and the button is retry, and the tag is retry. Let's try that again. Paper to draw, try again. Okay, we've got an array of, okay, yeah, that's because what we thought this append of multiple buttons isn't going to work. So what we need to do is buttons, pipe that into enum.map and do fn button now.frame.append frame comma button, and let's format that. Okay, rock versus paper, retry, scissors versus paper, scissors wins. It's a draw. Okay, so here we are. We are about 45 minutes in, and we do have a working GUI for this game. Now, let's clear up some of these logs because we don't really need them. Certainly all these restarting outputs. Okay, so that is a very simple rock, paper, scissors game. Now we have some options at this point. We can look at tidying up the code. It might be worth actually extracting a separate UI module that handles the management of the frame. It might also be nice to start keeping score, which we can do in the same module. And also it might be nice to make this a little bit more user-friendly. Now, I believe LiveBook has some functionality to extract. I think they're called LiveBook apps, and it will basically make this cell available as a more or less standalone app. I think it's over here, app settings, configure, and call it RPS. What does this mean? Let's make it single session for now. Don't worry about sharing. Actually, yeah, no, that's fine. Okay, we can do that. Yeah, and what's that? we can try that and let's see what happens. So I think we should be able to, oh, got an error. Okay, because I think, yes, we told it to stop and it can't stop. So let's try that. There we go. It would be nice actually if we can see the source, but can we edit it? We can debug it. Cool. And for this version of it, let's not show this debug message. And then if we go back, look, I thought we were making. Okay. We've restarted it. There we go. This is nice and clean. Rock versus paper. Paper wins. Try again. Rock wins. Congratulations. Okay, so there we have it. We have a working rock, paper, scissors game. We could, I believe, deploy this if we go to apps. We can go to dashboard. And we could, I think there was an option to deploy it as a Docker container if we wanted to. Over here. That's nice. You can have it automatically include the CUDA libraries for machine learning. We could, oh, nice. Okay, so that's for FlyRL clustering, but that might be okay. And that's nice. So we've got a basic Docker file. Nice. Okay, we're not going to do this right now. I'm going to close this because I think we might just about have time to implement basic scorekeeping. So how do we want to do this? I think a simple text output with a score we can do, and we can put that above all the buttons. Dot frame dot append frame, and what do we have it? Keynote dot. We can do HTML. We can do mermaid, images, markdown. To be honest, let's just do a very, very simple string for now. We can do score, and that is going to be 0 because that's the start of the new game. I'm going to put in the state, that's going to be score is 0. Okay, and we can run that. Score is 0. I don't like the way that's rendering. Let's see what happens if we do it as markdown. Keynote.markdown. New. Is that going to be any nicer? There we go, that's a bit better, isn't it? Okay. And now what we want to do is when we play the game, and we handle the choice, we will see that we have some results. The results are going to be a string, which is a bit annoying. It would have been nicer actually at this point if we had the results as an atom that we can match on more easily, but we can still fix this, right? So we can do type that into update score, which will get the state, and we can also pass it the results. And we're going to create a new function here, def update score, which is going to take a state, and it's going to take results. Now this is going to be, I think we can do some pattern matching on that result string. So we can do underscore anything that ends in congratulations means that they've won, and so we can do increase score, and that can be just passing the state, and then similarly anything that ends in both draw and win. Let's make losing have a different message, and then we can match on that. We can say if it ends in sorry. Then we can decrease score, and otherwise, whatever the results are, we don't really care. And in fact, we're going to just do nothing. We're going to return the state as it is in this case. And now we just need to implement the def increase score, and that will take a state. And what we're going to do is we're going to, in fact, let's pattern match this state so that we get the frame and score. Do we need to handle the display? I'm not sure we do. Or will automatically render on the retry if we append the new score, which we can grab that from there. This is definitely getting messy now, but we are on the home stretch. Attach that and do state.score. And I think then in here we don't care about the frame. We are just going to we can do map state score is equal to score plus 1. Actually, we don't decrease score. We don't decrease score when you lose, or should we? Yeah, let's do it. Why not? It's an unusual kind of approach, but it should be fun. Decrease score, and then score -1. Let's see what happens. The left arc. Okay. Okay, that's annoying. Okay, we'll have to get the whole results here, and then we're gonna do we're gonna have to work backwards and figure out whether it was a win or lose. So result, and we're gonna take the results, and then we're gonna pipe them into string.match, and we're gonna do a regex match here, and that is gonna be anything that ends with congratulations. Is a win. That will return a boolean. Yeah, so when this is so hacky, but we can do it. We can just push through and clean it up. Well, we won't clean it up because it'll be out of time, but we can do it better next time. When lose is results, and it must match. It must end with sorry. And draw. It's going to be the same thing. No, we can do this differently. We can do case, I think. No, we can do cond do and then we can do string.match results. Congratulations. And if it matches, what we do is under a case. I can never remember which one I need to use. Yeah, okay. Then we do increase score state. And then the same here. We do another clause here. Then we do increase score state. And then actually we don't even need to do anything else. I think we can get rid of all of this. I don't need to do an end match. I need the tilde regex, the regex sigil, and the same here. And that should end with that. And let's see, that should do it. Okay, right, so we've got some more about doing that matching. Don't need any of that now. We can start that. Okay, yes, so we just need to do here. Just the true there. Did nothing. Crashed. Start it. Okay, I've broken it. That's a shame. But we are just about out of time. Uh, so I will do better next time. Thanks a lot. Bye.